Okay, so this is how you answer question number 23. The question says, a man pushing a mop across a floor causes it to undergo two displacements. The first has a magnitude of 150 centimeters and makes the angle of 120 degrees with the positive x-axis. The resultant displacement, the magnitude is 140 centimeters at an angle of 35 degrees with the positive x-axis. Now we have to find the direction and magnitude of the second displacement. So first we to draw this out, that's our axis. And the first displacement is at about 120 degrees. So if this is 0, 90, and 180, that's about 120. And that's about 150 centimeters. The resultant displacement is 35 degrees and 140 centimeters. So this is 35 degrees and this here is 120 degrees. So first we need to find the resultant vectors, or the second displacement. So this is the resultant, and that's the first one. The second has to connect. So that would be out here. That's the second displacement. So one way, since we have one angle in the middle and two side lengths, we can use the law of cosines, which is basically a squared equals b squared plus c squared minus 2 times b times c times cosine of angle A. So we will assume that 140 is b centimeters and c is 150 minus 2 times b times c, and cosine angle A. So angle A is equal to here in the middle, so that's the big angle of 120 minus the smaller angle of 35. That is equal to 85 degrees, so cosine of 85. A squared. So A, once you plug this into the calculator, is 196 and 0.59 centimeters. So that's the magnitude of the second displacement. Now I need to find the direction. The best way to find the direction is to find the components of the first two vectors. So this was on 150 and this was 120. Now if you subtract 120 from 180, you'll get this angle here, which is 60. Y component, x component. This is 140 and 35 degrees is the angle here. So since this is the resultant, we found that the centimeters is 196.059. Now the angle will be the tangent of this. So with vectors, you can move them as long as they have the same direction and magnitude. And just let's say this is parallel to this, so that this angle here will equal this angle here if this was a straight line. The way we do that is we can find the difference between the y components, and that will be the y component here. And then with that plus the magnitude which we just found, we can find this angle here. That's what we're trying to find, which is the direction. So the way we find this angle here, which is the first displacement in the y direction, this is the resultant in the y direction. So displacement in the y direction is equal to sine of 60 times 150. And then the resultant displacement in the y direction is equal to sine of 35 times 140. And that equals 129.903 centimeters here and 80 centimeters here. So to find this is the difference between these two. Because if you look, this here minus that there is that. So displacement 2 in the y direction is 129.903 minus 80. And that is 50 approximately centimeters. Now with that equaling 50 and this, we can find the angle by sine of x is equal to 50 over 196.05. Sine inverse of 50, 196.05 is equal to 14 degrees. And that's just this angle here. But we want to find it since the other two were from the positive x-axis, so 360, which is the degrees of a full circle, minus 14, get 345 degrees. So direction is 345 degrees, and the magnitude is 196 centimeters.